In this video lecture, I am going to discuss something about Karnaugh map and its importance and why we have to use Karnaugh map and what is its main intention that we are going to see in this video. So here we are going to see something about what is mean by what is mean by a Karnaugh map. So but first we will use the word map. So usually what is mean by map, everyone will know. So if I want to go from some city from Bangalore to Delhi, then instead of writing all every cities in between Bangalore and Delhi, I can draw one map. So here Bangalore is there, here Delhi is there, and what is the important nodal point, so that I can connect this to this. Or sometimes I can have two nodal points I can connect from this, and this. So which is the shortest kilometer. Okay, so how which travel will be economical as well as less time and less everything seems to be beneficial to the user. That is the main aim of the map. So here what we are going to do is, instead of I am taking a traveling example, instead of traveling I am taking that concept of designing a circuit. So in the design of the circuit, which design will be more economical and less power consumption and simpler to design? These things we can arrive with the help of map, that is called Karnaugh map. So Karnaugh map is nothing but a graphical representation of a truth table. Karnaugh map is also a truth table equal to AB plus ABC plus ABC bar. If I take this means, if I draw a circuit, what happen? I can draw with a simple AND gate. Okay, this is ABC, and here I can take it as ABC bar. So this is another AND gate, for example. So if I want to add these two things, I need to put one OR gate. This is a circuit. Here, instead of seeing this as expression, see this as a circuit. Then will be it is useful. So here, how many gates are involved? You just count. One AND gate is involved. Another AND gate may be involved. So here I need to do ABC bar combination. So another AND gate is required, and one more NOT gate is required here, and one OR gate is required here. So how many combination means? AND gate is 2, and then NOT gate remains 1, and then OR gate also remains 1. So 4 gates are involved here. So if I simplify this expression, then what I will do, as per the Boolean logic, if I simplify means I can take AB as outskirts and C plus C bar becomes 1 as per the Boolean logic. You can visit how to reduce the expression using Boolean expression in the previous slides. So it becomes AB. So for this equation and this equation are mostly equal. If you realize means it will be mostly equal. So if I draw the circuit for this means I will get only a simple AND gate. So how many gates are required here? It is well understand that AND is equal to 1. So in order to make this more clear, what I am going to do is I am going here, I am taking the same expression, that is ABC plus ABC bar. So I am telling that this is equal to AB. So I am going to verify, I am going to show how it is equal. So ABC I am taking here. So what is C bar also I am taking here. So I am writing 0 0 0 0 0 1 0 1 0, different probabilities, 0 1 1, 1 0 0, and then 1 0 1, and after that 1 1 0, and finally 1 1 1. So if I write this means, so what happened, let us check. So if I multiply ABC means what you will get. So this is very simple. This is not A into B into C, A and B and C. This is the meaning. Like that only you have to study. And the C bar is nothing but not operation. We have to do that. So 0 becomes 1 and 1 become 0. That is the inversion operation. So 1 0 1 0 1 0 1. This is also 0. So if I multiply A or B or C means I will get 0. All numbers are higher only, you will get output as 1. Otherwise the output is simply 0. So I am getting 0 0. This is also 0 0 0 0. Final result will be 1. Similarly, ABC bar is equal to what? I have to 0 0 1, that is 0, and 0 0 0, that is 0, 0 1 1, 0 1 1, that is also 0, and then 0 0 1 0 is 0, 0 0 0 0 0 1 0 1 0 0 1 1 is also 0, 1 0 0 0 1 0 1 0 1 1 0 0, finally 1 1 1, that is also equal to 1. So like that you have to analyze. Once again I will explain. These things are somewhat confusing means once again I will explain. Okay, so right, so and click this 0 0 1, answer is 0, then 0 0 0, answer is 0, then 0 1 1, answer is 0, then 0 1 1, and sorry 0 1 0, answer is 0, then 1 0 1, answer is 0, then 1 0 0, answer is 0, 1 1 1, answer is 1, and 1 1 0, answer is 0. Like that I am getting. Okay, so if I add these two numbers, take this as column number 1 and this as column number 2. If I add these two things means what I will get? ABC plus ABC bar. Okay, how it is equal I am showing, I am trying to show. Okay, so now if I or logic, if I apply or logic between these two columns, I will get 0 0 0 0 0 0 1 1, right? So what I am trying to prove, this action and this um, uh, and operation are equal, like that I am trying to prove. Now I have to do the same operation with AB. After simplification I am getting the answer as AB. You can see here ABC plus ABC bar is equal to what? AB into C plus AB. So my concept is I need to prove ABC plus ABC bar is equal to AB. So what I am doing, I am going to do the AND operation between A and B. So you can tell 0 0 is 0, 0 0 is 0, 0 1 is 0, 0 1 is 0, 1 0 is 0, 1 0 is 0, 1 1 1 is 1. You can check these two things are equal. So by instead of using here, instead of using 4 gates and arriving at the same answer, I am using only one gate and arriving at the same result. So which is economical. While simplifying the expression, you can able to get the same answer with less number of gate and the same expected output. That means what is the advantage of that? The expected efficiency will be same, that is high, and cost optimization will be very low. Since I am using here 4 gates, I am using here 1 gate, so cost will be automatically reduced. Cost reduced and efficiency is high, and also power consumption is also reduced. So for this purpose only we are going for minimization of Boolean expression. So we want to minimize the Boolean expression in order to design a circuit with these 3 parameters. One is if high efficiency, low cost and low power consumption. At most in the first unit also we will see the same case in number system also. Our ultimate aim is we need to design a circuit with high efficiency, low cost and low power consumption. For that we need to reduce the Boolean expressions as much as we can, so that we can able to get a optimized circuit. For that purpose we are using this KMAP technique. KMAP is a graphical representation of truth table or modified version of truth table. So truth table is nothing but a table used to understand the operation of the circuit, any circuit logically. So if I want to tell different logic means, then I have to write, first I have to write a table, and I have to just write the skeleton on what basis this circuit will operate during different condition, what will be the circuit output. These things first I need to draft, then only I can able to design a circuit based on the arrived draft. So these things we are going to see in unit 3 and unit 4, unit 5. These things are completely designed in digital electronics. Here what we are going to see is how to use this map. Here we are having one map technique though, so how we are going to use that map, that is our main aim in this lecture hour. So first we will see what is meant by Carnot map. Carnot is the name of the scientist who come forward with one idea to represent a truth table in the form of map. So what are all the min terms available in the truth table? Just map that in the given map, so that you can able to simplify that in a meaningful manner. Like that, he came with one idea and presented his idea in a conference. That was nowadays, now itself, Carnot maps plays a vital role in designing any high level circuit, low level circuit or medium level circuit. Anything is possible by means of Carnot map. So what next, what are the types of Carnot map means? We can able to see here the 4 types, but many types are available, but we are seeing only 4 types here due to some constraints. That is 2 variable Carnot map, 3 variable Carnot map, 4 variable Carnot map, 5 variable Carnot map. Up to 5 variables Carnot map will function very efficiently. Even 6 variable also possible, but more than 5 variables somewhat complications will come. While drawing a map, we have to increase the map to some extent, so comparison will see somewhat complicated. In that aspect, another scientist come with one more idea, that is just why we want to map, we can alter the tabular column itself and we can find the same result. Like that, he give one method, but tabulation method is very feasible, but what is the main disadvantage is the process is very lengthier and time consumption. You can draw a Carnot, you can find Carnot map within 10 minutes means tabulation method, same technique, same answer you have to get by using 30 or 40 minutes. So the time consumption and the complexity of the tabulation method seems somewhat high. So usually we will go with KMAP. If KMAP seems much complicated means, then only they will go to tabulation method. So in the next lecture we will see how the tabulation method will work, and now we will see about the general discussion about what is meant by a Carnot map. So this is the general structure of your Carnot map. We are giving one map structure. This is generally a map. So it doesn't have anything. Overall map will be a square. That's all. So square shaped structure. So for we have to form cells here. Map means we can form some cells like this. So like this we need to form some cells. Okay. So it depends on the number of variables. So there are some formulas are there. That is capital N is equal to 2 power n, where small n is the number of variables. So if I am using 2 variable means, so I have to use how many cell means 4 cells. So assume 2 variables are A and B. So what we discussed, there should be 4 cells in a map. So you can see A, B are the 2 variables used. If you are using PQ means I have to write PQ here. If I want to use XY means, and then I can write XY here. That depends on the application, how the inputs are coming. That depends on the place where the Carnot map is going to use. So here I am assuming that 2 variables are A and B. So I am using variables here. So always use first term as a complemented term, that is taken as 0, and second one is uncomplemented term, that is 1. So this will be also 0 and this will be also 1. So the next slide we will see what is this. So now how many cells if you count means 1, 2, 3, 4. So for two variable Karnaugh map, how many cells we are using? 4 cells. Similarly, same category, if 3 variables are used, that is A, B, C, then what I have to use, I need to write A here and BC in the top corner. So then same thing we will follow. So how many cells if you count means I have to form 8 cells. So that is 2 rows and 4 columns. That is 1, 2, 3, 4, 5, 6, 7, 8. This is the 3 variable Karnaugh map structure. And similarly 4 variable means same. 16 cells will come. That is 4 rows, 4 columns. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 cells. So these are the 4 different structures of a Karnaugh map. 5 variable, same structure will be repeated once again, that I will tell in separately while discussing that. So now in this point, you just imagine how the layer structures of your Karnaugh map will work. So 2 variable means 4 cells, 3 variable means 8 cells, and 4 variable means 16 cells need to be coined in a 4 variable Karnaugh map or any structure that depends on the number of variables where we are using. So first we will see the 2 variable Karnaugh map in detail. So while forming a 2 variable Karnaugh map, you have to form like this. Similarly, we told 4 cells, that is 1, 2, 3, 4. And here as usual A and B, first complemented term and second one is uncomplemented term. Similarly in the column also. So complemented term I am calling it as 0 and uncomplemented term I am calling it as 1. So you need to combine and read this. So 0, 0 means 0. So as per 8421 code, you can see here 0, 0 means here 2 and 1 are there. 8421 coding, if you know, means it is very easy. So there is no 0 component here. So both are 0. If wherever I put 1, the corresponding number will be represented. 0, 1 means 1 is parallel with the 1. So I have to take that result as 1. Here 1, 0 means 2 will come into picture. 1, 1 means 2 plus 1, 3. Like that you have to identify. 0, 0 means no 0 here. So answer is 0. 0, 1 means 1 is here. So only I have to take that number 1. 1, 0 means 2 is there. In under 2, the 1. So based on this logic, I have written this number. You can see here 0, 0 means 0, 0, 1 means 1, 1, 0 means 2, 1, 1 means 3. So 0, 0, 0, 0, 1, 1, 1, 0, 2, 1, 1, 3. Like that this Karnaugh map is arrived. Similarly, 3 variable Karnaugh map means you can write one variable 8421 coding. You need to put 421. So 0, 0, 0 means answer is 0. 0, 0, 1 means answer is 1. 0, 1, 0 means answer is 2. 0, 1, 1 means answer is 3. 1, 0, 0, 4. 1, 0, 1, 5. 1, 1, 0, 6. 1, 1, 1, 7. Like that maximum 7 numbers are possible. So if I am writing here means you can see A bar A, B bar C bar, B bar C, BC and BC bar. If you look closely into the skeleton of the Karnaugh map, I have written 0, 1. Instead of 2, I am writing 3 and then 2. The numbers are reversed here. What is the reason for reversing this number? That is the question. So as per the Karnaugh map logic, each and every adjacent cell should vary with each other at least by one variable. Should be vary by only one variable. That is the rule. So if I compare 0 and 1, so what happened? 0, 0, 0. Okay. See here 0, 0, 0, and then next cell 0, 0, 1. 0, 0, 1. So if I compare these two things means 0 is common. Okay, this 0 is also common. Both are equal. This is also equal, but you can see top, this one is 0, this one is 1. So both are varying. So how many variables are different in condition? Only one variable. That is what the logic of the Karnaugh map. So we can use here. Whereas if I use instead of 3, I use 2, then what I have to do is I have to read these two things. That is 0, 0, 1, 0, 1, 0. Actually, if I write 2 here means what happened? Then 0 is constant, okay, I can consider. But 0, 1 varying, 1, 0 varying. But as per the Karnaugh map condition, each and every adjacent cell should vary by only one variable. But here two variables are changing. So I cannot use this condition. That's why I am replacing here 3 and here 2. So I'm just not shuffling these two numbers. This concept of writing 2 as 3 and 3 as 2 is called as gray coding technique. In first unit, I think we discussed about gray code. What is meant by gray code? Meanwhile, I will tell. So if I take 2 and if I want to convert it into gray code means what is the concept? 0, 1, 0. First, I need to take the number as it is. First number should be as it is. And first second number should be XOR condition. What is mean by XOR? Two numbers are different means you will get answer as 1. Two numbers are same means you will get the answer as 0. For example, 0, 0 means answer will be 0. 0, 1 means answer will be 1. 1, 0 means answer will be 1. 1, 1 means answer will be 0. You can see here both variables are equal means you will get answer as 0. Both variables are one different means you will get the answer as 1. This is the logic. So based on the condition, first variable will be as it is. You should not disturb. So 0 should be as it is. Next you need to do XOR operation. So 0 XOR 1 is what? 1. 1 XOR 0 is what? 1. So as per this, what I am getting, actually this number is 2. 0, 1, 0. 0, 1, 1 means what? This number is 3. So 2 will be represented as 3 here. That is called gray code. Similarly, if I take 3 means 0, 1, 1. If I do XOR operation, what you will get? First number will be undisturbed. 0 XOR 1 will be 1. 1 XOR 1 will be 0. That is called 0, 1, 0. Okay, this is as per the traditional method. 0, 1, 1 is 3 only. But after converting it into gray code, you will get the answer as 2. So here just we are not replacing the number. Instead of 2, we are not writing 3. Instead of 3, we are not writing 2. Using gray coding technique, we are just representing the number. This 2 only. But using gray code, this is written as 3. That you have to understand. Don't think that 0, 1 and after that numbers are shuffled. We are not representing the number. Here as usual only 0, 1, 2, 3. But based on gray code, this 2 is written as 3 and this 3 is written as 2. Similarly 4, 5. This 6, 7 if you convert means you will get the answer. This becomes 7 and this becomes 6. Similarly after that 8, 9 will come. You can also check. So 0, 1, 3, 2 and 4, 5. 7, 6. After that, once again 8, 9 will come. But what happen is, if I convert 8, 1, 0, 0, 0 means what number I will get? 1, 1 XOR 0, 1 and 0 XOR 0, 0 and 0 XOR 0, 0. This become 12. Okay. So number will be what? Here 12 will come. So automatically 13, 15 and 15 and 14. Okay. And similarly what? Once again, this is confusing. So I will write here. So as per the logic 0, 1, 3, 2 and then 4, 5, 7, 6 and then after that 15 you are getting 12, right? 12, 13 and then 15 and 14 and automatically what will come here? 8, 9, 11 and 10. This is how a Karnaugh map is written. This is the logic. Usually the understanding is 0, 1 you have to write 2, 3. But what is the reason actually? Why you have to reverse this number unnecessarily means each as per the Karnaugh map principle, each and every adjacent cell should vary with each other at least by one variable. Based on that logic only, this table is formed and writing the numbers in representation of another number 2 as 3 and 3 as 2 and 8 as 12 and 12 as 8. These things are called as what? As per the gray coding technique, we are completely reforming the Karnaugh map. That's why Karnaugh map is also called as gray coding table, gray code table or gray code technique, whatever maybe you can use the words. Okay, this is the reason why we are changing the numbers from one cell to another. So if you check entire Karnaugh map, you can see the operational condition, how it is working, everything. So here, for example, randomly we will check. So this is 0 0 0 1 1 1 1 0. Similarly 0 0 0 1 1 1 1 0. So if I check these two conditions, for example, 13 and 15 I will take for checking purpose. So for 13, what is the number you are observing? 1101. This is 13. And 15 is 1111. So you can check how many variables are changing here. 0 1 only, third position only changing. So this is acceptable. Similarly, in Karnaugh map, what is the only drawback is you cannot compare these two diagonal components. Only adjacent cells can be compared. 0 1 can be compared, 0 4 can be compared, 1 5 can be compared, 8 and 12 can be compared, even 0 and 8 can be compared. These two cells can also be compared, no problem. Just for example, 0 0 0 0 1 0 0 0, what happened? Everything are equal, only one variable, so possible. Corners are also equal. Each and every adjacent point, everything will be like equal. But what is the only drawback or violation in Karnaugh map is you cannot able to compare the cross points. Suppose if I compare 2 and 7, you will not get the answer. For example, 0 0 1 0 0 1 1 1. If you check this means, see here, complete collapse. These three things are totally varying. That is not acceptable. That's why Karnaugh map is used only to frame the pods which are adjacent to each other. It will work only for adjacent sets. It will not use to join or combine any diagonal cells. We cannot able to combine. So these are all the things you need to. While coming into the picture, we will see completely. I think it is understandable to all. So after that, we are going to see different how to use Karnaugh map. So here it will be clear. You can see here, if there are two ones in a Karnaugh map, how to fill the Karnaugh map, that I will tell after these things. So first, if two ones are adjacent to each other means you can form it as a pair. Similarly, two ones are adjacent like this means that is also possible, but diagonal combinations are not possible in Karnaugh map. Already we told what is the reason. Since diagonal components means it will vary with two variables, that is not possible in terms of Karnaugh map. So what are the different groups possible in Karnaugh map means 8 groups, group of 8 adjacent ones are possible, that is called octet, and group of 4 adjacent ones, that is called quad, and group of 2 adjacent ones, that is called pair, and only one is available means we cannot form any group, that is called as a unique term. Okay. So while forming a groups, we have to give preference like this. First 8 number of ones should be given preference, 4 number of ones after that. Not possible means then you have to go with 4 ones. 4 ones also not possible means then you have to go with 2 ones, and then only you have to come for unique term. So these are all the things of basics of Karnaugh map. Let us think how to form a Karnaugh map, and we can verify one simpler thing, and then we can, if possible, we will check what are all the happenings things. So first one is I am going to take one AND gate. So AND gate means what? You can check here. This is the AND gate symbol, and if I give AB means, so y is equal to what? A dot B. So how this equation is coming? That is the everyone's question. Sir, you are telling AND gate, write A is equal to A dot B, dot stands for AND, like that. How it is coming means, first you need to write the truth table of the AND gate. So as per the AND logic, both variables are high if both variables are high. Name itself it is right now A and B. Both are high means you will get the answer as 1, otherwise you will get the answer as 0. So A, B, so y is equal to what? A and B. So 0 0 0 1 1 0 1 1. So both are low, answer is low. One variable is low, answer is low. Here also low. Here both variables are high, A and B are high, so we will get the answer as high. This is the truth table. So here, how many variable of Karnaugh, which Karnaugh map type we need to use means two variable type. So for two variable already discussed, how many cells we have to use? 4 cells. Since 2 square 4. So I am dividing this component as 2 rows and 2 columns. So here I will take A and here I will take B. So A bar B, A and B bar and B. So while writing 0, 1, 2, 3, I can write like this. So first you can check 0, 0 is 0. No need to write here. 0 means don't fill. Only we need to write the min terms. So sum of product of sum that you can check means which are all the minor component that min terms are used to form the Karnaugh map. That is the meaning. Here minimum number of term is 1. That's why I am using 1 to fill this Karnaugh map. Majority of terms are 0. That will not help here. Okay. So 0 is 0, 0, 1. That is also 0. No need. 1, 0 is 2. No need. 1, 1 is 1. So I will fill a 1 here. So you can see only one element is available in this Karnaugh map. So I will round it and I am called this as a unique term. Call this as a unique term. So if unique term means what means how to write this answer means this unique term will correspond to row and column. So what is the row answer? What is the column answer? Row is equal to A and column is equal to B. So while writing the answer, you need to combine these two things, that is A dot B. As per Karnaugh map logic, a min term can be represented as a sum of product term. So here only one term is available, so product term is nothing but A dot B. That is why the answer will be from this table y is equal to A dot B. That's why we are always writing the Boolean expression A dot B like this. Similarly, you can try for OR gate also. So I am trying OR gate now with the different variables I will try. So y. Here I instead of AB I can use xy. So I can write it as x plus y. Okay. So plus not x or y. Okay. So either or. So either x should be 1 or y should be 1. Then answer will be high. Otherwise the answer will be 0. So x, y, and here also I am having y. So I am taking it as f for confusion, lack of clearing the confusion. 0, 1, 1, 0, 1, 1. So here both are low, answer is low. One variable is high, answer is high. Here also high, both are high also, answer is high. So here what I have to do, x and y, what is the hierarchy? First one is complemented, second one is uncomplemented. Here first one is complemented, second one is uncomplemented. So if I fill up this means 0, 1 becomes 0, 0, 0 becomes 0, no need to fill. Remaining all numbers I need to fill. Now you can check here, 1, 1 are adjacent to each other. So what I can do, I can form this as a pair. I can form this as a pair. You can check here. I can form this as a pair, one pair. Similarly, 1, 1 is existing. You can check here. Always after forming a pair, these two become one group. After this one is what? Separate. It is unique. So you start here. So you put a box, starting mark. Okay, starting mark. And then try to combine with other groups. So I can combine like this. So this is what we call it as pair 1 and this is what we are calling it as pair 2. Now what will be the answer we need to write. So pair 1 means corresponding row and corresponding column. For pair what happened, pair 1 corresponding row, this one contribute to x bar and this one contribute to x. So both thing will cancel. So row will not come here. And for column, these two ones contribute to a single column y. So I am getting y here. Similarly, for pair 2, what happened? Two rows. These two columns are contributing. It will cancel each other, and a single row is a contributing row. So I will get. So here, what happened? Row is equal to x, and the column will not be affected since both things are cancelled. So while writing the answer, what is the simplest method? Is f is equal to p1 plus p2. Pair 1 plus pair 2. Pair 1 answer is y plus x. So you can rearrange x plus y. That's why how we are getting the Boolean expression from the Karnaugh map. So you can able to arrive expression for a particular circuit, or you can able to design a particular circuit in a optimal, efficient and low power based designs. Everything is possible with the help of Carnot map. So in the next session, we will see some complicated problems, or I can take one case study and we can see how to design the design that circuit using a KMAP. That will be done with the next lecture. So up to this, I think overall summary is what is meant by a Carnot map means. Carnot map is nothing but a graphical representation of truth table, and the truth table, this Carnot map is mainly used to minimize Boolean function. Why we need to minimize Boolean function means our ultimate aim of designing a circuit means that circuit should be economical, low power consumption type, and also it should be a simpler in design. For that purpose only we want a minimized component with high efficient nature. For that only, for arriving such type of circuits, we use Carnot map for deriving the feasible equation. Then types of Carnot map depending on the variable and application, it varies from 2 variable to 5 variable, and based on the extension of variables, we can go with another technique also, that is called tabulation method. If Carnot map become more complicated means, then only we have to go tabulation, since tabulation is little time consuming in nature. Next, general structure of Carnot map we have seen. So n is equal to 2 power n to calculate number of cells. So 2 variable means it contains 4 cell, 3 variable means 8 cell, and 4 variable means 16 cell. In Carnot map, that cells are in the 3 variable onwards, the cells are reversed. Since as per the Carnot map logic, each and every adjacent cell should vary with each other by at only one variable only. So for satisfying this condition, gray coding logic is applicable here. In that 2 is represented as 3 and 3 is represented as 2. Similarly, entire Carnot map, we will use gray code technique and transform the complete map into a gray coding technique map. So these numbers will be like this. This is the general idea: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is, here what actually come means 8 should come. 4, 5, 6, 7, 8 will come. If you do 8, gray code, if you convert means you will get this number 12. Similarly, 8, 9, 10, 11, 12. If you convert 12 means you will get 8 here, say, as per gray code. So that's why these are formed here. After this combination, if you compare any adjacent cells, you will get only one variation in the variables, among the variables. In diagonal combination is not possible in Carnot map, since diagonal combination will give more than 2 variable change. That is, usually we will not follow diagonal combinations in Carnot map. And how to use Carnot map we will see. That is, adjacent cells will be considered and diagonal cells are not considered in case of Carnot map due to the policy of only one variable change policy. And what are the possible combinations in Carnot map is group of 8 ones are possible, that is called octet, group of 4 ones, that is called quad, 2 ones, that is called pair, and only 1 that is called a unique term. So you have to give priority like this: 8 ones, after not possible means after that 4 ones, and then 2 ones, and then only you have to come to unique term. And we see about the AND gate formation. Here how the truth table is mapped. We have to map only min terms, leaving the major terms. So here min term minority is 1. So I am taking that, and corresponding rows and corresponding columns are taken into consideration. So I am getting the answer in the form of sum of product. So A row and column answer, that is A dot B. Similarly, OR gate we formed. So 2 pairs are formed here, corresponding row and column answers. So if 2 columns are contributing means both get cancelled, it will not come into picture. And similarly, 2 rows are contributing means it will not come into picture. In case of P1, you can see 2 rows are contributing, so it will not be this. It is not so cited here, and the column is nothing but it corresponding column only written here. Similarly, here rows are contributing. Rows are contributing row is written here. Since both columns are contributing, we are not writing here. So answer is nothing but pair 1 plus pair 2, or whatever may be the combination, addition of sum of product. So sum of the two product terms. So we will get y plus x, like that. So with this preliminary idea, you can able to construct any circuit for any concept by using Karnaugh map. So that circuit will definitely serve as a efficient, low power and simpler designed circuit. That is the main aim of studying this Karnaugh. So thank you everyone for watching this video. You can comment in the section how the video, any doubts means you can comment in the section so that it will be cleared, and try to subscribe the channel. Thank you.